Say this is you, and imagine that you work for a bike rental company and you have bikes that you would like to rent. Let's focus on single bike at a time, and let's say you have this bike. So here's your bike ready to be rented. And let's talk about a specific day of the rental. And let's say for the day tomorrow, your bike is available from midnight, that is 0 a.m., until 4 p.m., that is 4 p.m. In other words, your bike is available for this time of 17 hours from the time 0 a.m., that is midnight, until the 4 p.m. So let me number these hours. So we have total 17 hours slots, first slot, second slot, third slot, and so on. Say there are 11 people wanting to rent the bike, wanting to rent the bike for the next day, that is beginning from midnight until 4 p.m. Let's see what are the demands of these 11 people, that is during what durations they want the bike to be rented for them. The first person wants the bike to be rented from 1 a.m. to 4 a.m. From 1 a.m. to 4 a.m. This is the first demand. The second person wants the bike from 3 a.m. till 5 a.m. Third person wants the bike from midnight until 6 a.m. Fourth person wants the bike from 5 a.m. to 7 a.m. Another person wants the bike from 3 a.m. to 9 a.m. And the last person wants the bike from noon till 4 p.m. Now, since you own the bike rental company, what you would like to do is rent this bike to the maximum number of customers. That is, your goal is to rent the bike to maximum number of customers. Now, obviously, if you rent the bike to this guy, you will not be able to rent the bike to almost any other person, right? So your goal is not met. You might choose to rent the bike to this person, and then after that, you could rent it to this guy and then to this guy, eventually serving three customers. So that probably is also not the best choice. So in this way, what we would like to do is find a way or come up with an algorithm that allows us to find what is the maximum number of customers that I can serve given this schedule of demands and the total time slot that I have my bike available. Formally, we say that in the activity selection problem, we have a set of proposed activities. In this case, we have 11 activities, which we represent by using this capital letter S, equals all the activities are represented using this letter A1, A2, A3, up to AN. In this case, we have 11 activities here. Now, each of this activity AI has its own start time, SI, and its own finish time, FI. So obviously, always SI will be smaller than finish time, FI. We say that two activities, AI and AJ, are compatible if the intervals for AI and AJ do not overlap. So AI may have an interval such as this goes from SI to FI, and AJ may have an interval, for example, SJ to FJ. So if these two don't overlap, then we say that these two activities are compatible. So here, activities such as this one and this one are compatible, whereas activities such as this one and the second one, so this and this, are not compatible because they overlap. In other words, for two activities to be compatible, it should be such that we should be able to share our resource, in this case bike, to both the activities. And the goal for us is to select a maximum size. So from all of these activities, what we would like to do is select a maximum size subset of mutually compatible activities, So in other words, what we want to do is from this set S, we want to obtain a smaller set S in which all the activities are mutually compatible to each other. Now I can create a table to put all the activities into a single place such that they are sorted by their finish time. For this, let me number all the activities using this letter I, and then I represent their start time using SI and their finish time using FI. So the first activity has a start time of 1 a.m. and finish time of 4 a.m. The second activity has a start time of 3 a.m., finish time of 5 a.m. The third activity has a start time of midnight and finish time of 6 a.m. So with this table at hand, the problem is to create a subset of activities, come up with this subset such that all of these activities are mutually compatible. And this should also be the maximum number of activities possible. Now say that we would like to rent this bike to this guy and also to this guy and to this guy. Now these three, in this case, these would be a subset of A3, A9, and A11. So this is A11, this is A9, and this is A3. So these are obviously mutually compatible activities. However, this is not the maximum set. So this is not maximum set. For example, this set where we choose this as the first activity, second activity, third activity, fourth activity actually has 4 activities in it, and this could be one of the maximum size mutually compatible subset of activities.